With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, ring is fixed on the horizontal surface and a rod starts rotating with constant angular velocity omega fixed at O as shown in the figure. Find the magnitude of the velocity of the point of intersection of rod and ring when alpha becomes 90 degree. Here we need to find this net velocity of this point. Let's say we name this point here as S. We need to find here this magnitude of velocity of this intersection point here. So suppose we name this point S and net velocity here is along the tangential direction. We say here as V, which we need to find out. So we join a line from center to this point S, and this is the radius here of this, let's say, ring. Now about this, let's say, axis, this here is moving with angular velocity as omega. Hence we can say here the resolution of this velocity along the, let's say here, perpendicular will be equal to, we can say here, this point S will be moving in circular path, we can say here, with respect to point O with, let's say, angular velocity as omega, and we name here the distance between O to S. Suppose this distance here is our, let's say, we can say here as X. So we can say here this point will have this, let's say, component here. We can say here if this angle here is theta, we know here this total angle is 90, and this angle shall be 90 minus theta, and we can say here this angle also simplifies as theta. Hence we can say here this, let's say, resolving B along this direction, B cos theta here comes out to be our omega into, we can say here as this distance from the point O about which this rod here is moving with angular velocity as omega. So from the triangle we can say here, from this right angle triangle COS, we have here as cos of theta as base by hypotenuse, which here is x upon r. Hence this simplifies as we can say here cos of theta here becomes equal to, we can say here as x upon capital R, which here is equal to omega into x. X and x cancels out. Hence we have the velocity given here as omega into r, which here is our option number 4. Hence this velocity of the intersection point of rod and ring when alpha becomes 90 is r omega, which here is option number 4. Hence 4 is the correct answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.